Okay, so today we're going to start on angle measurements. Okay, so let's say if we have our circle. Well, that actually should be a little more even, but you get the idea. Okay, and here we have our radius. Okay, so radius of r, that's the distance from the origin to the actual circle itself. Okay, and we know this is our theta, which is the number of degrees that we actually had to move from our initial point to our terminal point. Okay, so if we wanted to find the distance from here to here, that's actually s. So we can find that distance, or arc length, of the circle. Well, not really the circle, it's more of the section of a circle. That'll be s equals r times theta. Okay, where s is your arc length, r, that's your radius, and that's your theta. Okay. In most cases, your theta would have to be in radians, because if you calculated with the theta in degrees, you'd get the wrong answer. But it actually does have to be in radians, because you're measuring using s. So your theta here, that's just your degrees, but your radians actually measure from the outside. All right, so let's say, for example, a circle has a radius of 4 inches. Find the length of the arc intercepted by the central angle (4 pi over 3 radians). Straighten that up a little bit. Okay, so we know that our radius is equal to 4, and our central angle is 4 pi over 3. Okay, that means your length of your arc, which is r theta, is going to equal 4 times 4 pi over 3 radians, which is 16 pi over 3. But if on the homework, if they actually put it into decimal form, it would round to be about 16.76 inches. But on the exam, this would be how you would write it. All right, any questions on that one? Okay. Now with this one, sometimes they'll give you the arc length and the radius, and you have to solve for theta. So you can actually do that also. So just a quick note. S equals r theta, where you solve for the arc length. If you divide both sides by r, theta equals S over r. This is where you can actually solve for theta. Solve for the angle. And if you want to find your radius, if you divide both of these by theta, and that's if you want to solve for your radius. Okay. You can use the same formula to solve for any one of them. So sometimes they'll say, okay, the arc length is this, and the radius is that, solve for theta, and you can just plug them in. All right, any questions on that one? All right, thought I had an example here. All right. Thought I had another one. Yep. Okay. Oh, anyone still writing? All right. Okay, so now we're going to look at the area of a circular section. Okay. So we know the area of the entire circle is pi times the radius squared. Okay, so that's if you have an entire circle and you want to know the area of the entire thing. Okay, so what if we had theta, number of degrees, was the area, or what is, not what if, of the area of a circle. Okay, so what if we had a circle and we didn't want to know the entire area, we just wanted to know the area of a small piece. Okay, so in this case, our area of the entire circle is still pi times radius squared. Move that over a little. But we only want to know a small portion of it. So we really only want to know a small theta out of the entire 2 pi. Okay, not the whole thing, just a little bit. Okay. So in this case, the 2 pi's cancel out. Okay, so we end up with the area equaling, well, might as well put it in order. Let's say theta over 2, which is 1/2 theta, times radius squared. Okay, and this is the area of a section of a circle. Okay, so let's say, for example, I want to find the area of a sector with a central angle. We'll bring that up some. Of 1 radian. In a circle of radius of 10 meters. Okay, so we know that the area is equal to 1/2 theta radius squared, or radius squared theta, however way you want to write it, same thing. Okay, so 1/2, we already know, I'll just write it as a decimal. Or I'll leave it like that. Okay, so we have 1/2 times our radius squared, so that would be 10 squared, times theta, which our central angle is equal to 1. Okay, so actually that's 10 meters squared. Okay, which would be 1/2 times 100 square meters times 1, which is just 50 square meters. Okay, so sometimes they'll actually just give you an image and have you figure it out from there. So let's say if we have, for example, if you want to find the area, and they give you a circle, and this is our theta, let's say that's 80 degrees, and our radius is 8. And we just want to know the area of that section there. Okay. Now your degrees, you have to convert it to radians first. So we're going to convert 80 degrees to radians. Okay. So to convert to radians, remember you have to multiply it by pi over 180 degrees. So 80 degrees, I'm going to multiply that by, well, let me move that down a little bit since I don't want it to get mixed in with the 80 degrees above it. So 80 degrees, remember you multiply that by pi radians over 180 degrees, where your units of measure here cancel out. So 80 pi over 180, which simplifies to 4 pi over 9 radians. Okay, so now we plug that into our formula. So the area is 1/2 times the radius squared theta, which is equal to 1/2 times the radius, which is 8. 8 squared times theta, which is 4 pi over 9. So you get 64 divided by, well, you can say 1/2 times 64 times 4 pi over 9. 64 divided by 2 is 32. So 32 times 4 is 128 over 9. So 128 pi over 9, which if you had to simplify it on your homework, it would be 44.68. All right, so any questions on that one? Yes. Yes. Yep, it'll always be 180, only because if you remember that pi is actually equal to 180 degrees. So if you divide both sides by 180 degrees, you get pi over 180 degrees equals 1. So technically, we just multiplied it by 1. All right, no problem. All right, any other questions on this one? Oh, man, that was a big sneeze. All right. Oh, anyone still writing? Okay, so now we're going to look at inverse trig functions. All right, so let's say, for example, let's say if you want to find sine of tangent inverse of -1. Okay, so before we did where you had sine and sine inverse canceled out, cosine and cosine inverse canceled out, tangent and tangent inverse canceled out. When it's the same, they can both cancel out. But in this case, you have two different ones. Okay, so when you have it where you have two different trig functions, the first thing you want to do is solve what's inside first. Solve the inside first. Okay, so we know just from the inside that tangent inverse of -1, we can just make that y. Okay. So if we apply tangent to both sides, we have tangent of y equals -1. Okay. So we know that since tangent of -4 equals -1, we know that y is equal to -4. Okay. So now we solve the whole thing. Okay. So sine of tangent inverse of -1, remember we just made it equal y. So that's just sine of y. And we solved for y already, which is -4. So sine of -4. Remember, sine is an odd function, so that negative can just go right out to the front. That's equal to negative sine of power 4. Okay, so we know that sine of power 4 is equal to square root of 2/2. So this just becomes negative square root of 2/2. And that's your answer. All right. So any questions on that one? All right. Okay, so let's say, for example, if you wanted to solve cosine inverse of sine of 5 power 4. Okay. So again, first thing you want to do, solve the inside. Okay, so if we solve the inside, we have sine of 5 pi over 4. Okay. Now, if you don't know it off the top of your head, you can always figure it out. Okay, so if you graph it here, so you know that 4 pi over 4 would equal pi. So you know that's there. This is your pi over 2, and this is your pi. So 5 pi over 4 is somewhere in quadrant 3. Okay, so you know if it's in quadrant 3, your reference angle, anybody remember the reference angle for quadrant 3? Nope, that your 270 is your degree here. Because remember, in quadrant 1, it's theta. In quadrant 2, it's pi minus theta. In quadrant 3, it's theta minus pi, that's it. Because remember, in quadrant 2 is pi minus theta. You just flip those two around, it's theta minus pi. Uh-oh. Or you can do theta plus pi, same thing, depending on which value you get here. So theta minus pi, here, your theta is 5 pi over 4. So your reference angle, just theta minus, I don't know why I put that little line over this one. Just theta minus pi, which is 5 pi over 4 minus pi. Instead of pi, you can put 4 pi over 4, which is pi over 4. Okay, so that means sine of 5 pi over 4 is in quadrant 3. So since quadrant 3 is negative, y is negative. Let me stop. Where is it? Actually, let me write that note down. Y equals sine of, let's say sine of theta. I'll leave it. Sine of theta is negative in quadrant 3. Okay, so that means your reference angle is going to be negative. So sine of your reference angle is negative. Okay, so that means your sine of 5 pi over 3 will have a reference angle of sine of pi over 4. Okay, so we know sine of pi over 4 is square root of 2 over 2. And we know it's negative since y equals sine is negative in quadrant 3. Okay, so we end up with negative square root of 2 over 2. Okay, so we have the cosine inverse of negative square root of 2 over 2. Okay, so once you solve the inside, then you do your second step and just solve. Okay, so that means cosine inverse of sine of 5 pi over 4 will equal cosine inverse, and remember we made that equal to y. I might as well put that. Of negative square root of 2 over 2, since we already solved it. And if we want, you can make that one equal to y. Yes? Oh, just me messing up. Sorry about that. Thank you. All right, so from there, we know that cosine of pi over 4 equals square root of 2 over 2. Okay, we just have to figure out negative square root of 2 over 2. Okay, so we know we have square root of 2 over 2 for cosine of pi over 4. So we know that cosine of 3 pi over 4 equal, actually I should have put that underneath it. Cosine of 3 pi over 4 equals negative square root of 2 over 2. So that means cosine inverse of negative square root of 2 over 2 is actually equal to 3 pi over 4. All right, so any questions on that one? All right. Let me get a good example here. Get a good one. That looks to be a pretty good example. All right, and I'm still writing. All right. Okay, so let's say, for example, so if you want to simplify cosine of sine inverse of negative 12 over 37. Okay. So once again, we're going to start off with the inside. Okay. So instead of y, I'll use theta. So we'll let theta equal sine inverse of negative 12 over 37. Okay. That means that if you apply sine to both sides, you have sine of theta equals negative 12 over 37. Okay. Now we know for inverses, if you remember, for sine inverse, it has to be between negative pi over 2 and pi over 2. So if you look at the graph here, this is your pi over 2, and this is negative pi over 2. It has to be in one of these two quadrants. So the only way y is negative is in quadrant 4. So in quadrant 4, y equals sine of theta is negative. Okay, so that negative 12 over 37, you know it's in quadrant 4. And actually, I'll show you another way to figure it out a little later, but this is kind of the prequel to that part. Okay, so we know we have our x squared plus y squared equals 1. Okay, so that's our unit circle. We know our y is equal to sine of theta, so that gives us x squared plus negative 12 over 37 squared equals 1. Okay, so if we subtract, we'd end up with x squared equals 1 minus negative 12 over 37 squared. So we have x squared equals, actually go ahead and write to the end, because you won't have one this difficult on the exam because you won't use a calculator. So if you plug that in, you end up with x equals